This snapshot from EDGECAM Simulator shows a lathe turret with turning, drilling, boring, and live tools. This snapshot now has shared tools in those stations on a twin spindle type machine. Today we're going to be talking about the tool mounting blocks that hold these tools to the turret. We appreciate this video courtesy of Index. We've chopped it down a bit to some relevant things, and the full video is available at the link provided. Notice the tool mounting blocks on the turret. These are interchangeable and can be replaced with different mounting blocks suited to hold different types of tools that the machine can use. When we consider implications on post-processors, many post-processors that have graphics will include the graphics of the turret, but do they include the various tool mounting blocks or tooling program used in the customer machine? Doesn't matter whether those come from factory or a third party, we want to dig into how to put those into your post. So let's begin with looking at this quick program where we have a turning tool and a fixed drill already created. And when we go to Simulator, we see Simulator shows the graphics of the machine, but the tools just hang off in space off the turret, and we do not see the tooling program or tool mounting blocks that would be used to hold those tools, locate them on the turret. That's what we're going to address. So I'm going to go over to Code Wizard, and we see that the code generator portion where NC code's handled is taken care of. The machine tree lists the different components and the axis configuration, but on the fixture page, there are no tool mounting blocks added at all, and that's what we're going to do today. So let's start by opening an example model. This model is provided by the machine tool manufacturer, and in this case, it's not only the machine components, but they also included the factory tooling or tool mounting block program where the various tool mounting blocks are arranged on the turret for convenience. Let's start adding tool mounting blocks to our Code Wizard post-processor. Before we do that, I want to point you to some important reference information. So in Code Wizard, Help, and the Help topics, we're going to go to the Machining Simulations section and look at the key parameters for turning. Now in a turning post-processor, the turret home position is important, and then from the turret center to the turret edge, we have the tool set or mounting distance, and we're going to need to know what that is. Let's close down that help reference and jump back to this example and show where that location is determined. Now this turret post has holes through center, and we've stretched a line from turret edge to turret edge. And if I measure the point at the mid of that line, the coordinates in X and Z of that point are our turret home position, from the machine 0 to the turret center. If we go to the machine section, we can see that those are plugged in. Now this is a bit of a review of some basic things, but we see those there. And then on the mounting page, there's this value for the mounting position. Let's go see where that's taken from. Let's turn on the display of the turret for a moment and observe that this turret is designed for live tooling, where the turret has a socket through which the tool mounting blocks connect to the drive mechanisms, and that's the place where the line's been stretched through. If I measure end of the line to center of the turret, we see the same coordinate set that's been put into Code Wizard for the mounting position. So this turret's home position is at the center of the turret in X, and the location where the bore is in Z, and that home position is then where the mounting block reference is taken from. Some post authors may use the turret face. In this case with live tooling, using the socket seems to make more sense, at least to the post author. We see turret midlines. Wherever the turret home position is, that's where the mounting position picks up from. So let's go now and start to add mounting blocks. In Code Wizard, we can select the turret and then add a variety of mounting blocks. We'll add a radial block. We can go to the radial option here, choose properties, and even change the name. So if you have multiple radial mounting blocks that are used for various things, maybe turning tools, others for cutoffs, you could name them appropriately. We'll assign it into a turret. And then there's the block that is the model that we see visually in simulation. Notice that in addition to changing color and other things, it is tagged as a fixture. And then there's the parametric values that can be used to shape that cube. Well, I don't really want to use the parametric values. Well, we could change that, and that could work for some applications. I actually want to use a solid. We want to use the mounting block program and have excellent visual simulation. So let's go do that. I'm going to open up the radial turn tool. We've isolated this tool and put it into the go position. When you go to your views and you choose front turn, the go position should look the way the mounting block will work in the upper turret of the machine. So you see that the X position points toward the center line of the machine, the Z position is aligned with the Z of the machine, and the origin coincides with the tool's mounting position that the post author decided. So with this tool in the proper go position, we can simply select the solid that we want to use as the mounting block, right-click and choose Output Model from the shortcut menu, and that pastes it into a temporary clipboard where we can now move to Code Wizard, and we can first delete the parametric block and then paste the model that we've grabbed from EDGECAM. How do I know it's there? Well, I see the item. I'm going to need to change it to be a fixture for simulation classifications, and we can see the preview window shows that mounting block. Next, we'll add a mounting block for the boring tools. So that'll be an axial block. That adds both the tag and then the parametric block. So I'll change the tag or the item here to name that I want. Assign it to the upper turret. And then I'm going to go strip out the parametric mounting block and replace it with my own solid. So first deleting that, then going to EDGECAM, where again we've taken a model, isolated the model, and looking from the front turn view, the orientation should match the way that the tool mounting block will look in the upper turret of the machine. As before, the x-axis points to the center line, the z-axis points the direction of the machine, and the origin matches where this will assemble or bolt up, if you think of a CAD assembly, to the tool set position we specified in the post processor. So I can select the solid model, right-click, Output Model, and then in Code Wizard paste that model in. So now when we go and look at the item, we're going to change the type to be a fixture, and you see the preview of this as well. Great, let's test this out. So we'll save the Code Wizard file and then compile it, because anytime you make a change, you do need to compile your post, and these are part of the post processor. Let's go back to our test part that we were looking at earlier. Now, after making changes at this level to a mounting blocks, you need to reload the machine. So if you don't have the machine tree active on your interface, you can add it from the Windows menu and then right-click over the machine and reload the machine. This loads the changes to the kinematic tree, including the new fixtures. And so now when we go edit the tools that we've already built in our CAM session, we're going to go out to the Tool Store tab, and here we can go to the mounting block list, and suitable mounting blocks are shown. This is a radial tool. The only one I see are radial type tools. Notice that we also see the name. So for axial tools in this case, you see the name that we've assigned to the block. Again, you can have multiple tools of different types, and the name helps keep the various tools sorted out. When we go to Simulator, we can now see the tool mounting blocks on the turret, which is great, but the tools don't have the right stick out. And that's what we'll deal with next, is how to get the stick out in place. Let's work on tool stick out. This is done on the loading page, and the values used are referenced from the tool setting position assigned in Code Wizard. So for the turning tool, Z-gauge will get the insert tip to a suitable position off the block, but I want the tool to hang off the block by 2 inches, and that's an X value on a radial tool. So my tool mounting block plus 2 more inches. On the drill, my X position gets the drill into the center hole in the block. My drill hangs off in Z. So I've got the Z value of the block plus my hang-off distance. And we'll be talking about how to get those values for the block. While we're at it, we'll go ahead and remove the holder that would be appropriate to a mill, but isn't needed in the turning center. When we go to simulation and have a look, we not only see the blocks, but now the tools are in the correct position within those blocks. Again, the values are taken from the mounting position at the center hole. So center hole to tool tip edge in Z and X is what we need to know. Well, how did we know those values? Let's go have a look at that now. Let's go back to our mounting blocks and show how to collect this information. So on the axial block, I'm going to need to go find out what the Z position at the front face is and the X position at the center of the bar. These are where this tool stick out would be taken from. The values here are values that are referenced off the origin of this file, which is the tool setting position of CodeWizard. So we're going to take these values and note them down, write them down somewhere for future reference. And then we're going to go to the radial turn tool and grab similar information. Now this is a different block, and while we need similar information from the Z of this face and then from the X of this face, the values themselves are possibly different across different blocks. So again, we'll collect this key data. Now that data is used to assist us at getting the core values for different blocks that need to be considered when trying to plan out tool stick out. Okay? How far does this tool stick off the tool setting point in CodeWizard? And we're going to want to store those somewhere. Could be a document, could be a data table, could be a spreadsheet, or maybe you make a CAD assembly and make yourself a detail drawing like we've done here with this example. You could use Hexagon's Designer product to do that if you wish. Now that you have that data, this will assist programs, and for standard tools that you keep in the machine, a job kit is a great way to quickly store this data. Let's close with simulator snapshots. The first application example is a multi-turret machine where the tool mounting blocks for each turret have been added to CodeWizard Post-Processor. The next application example, the lower turret mounting blocks for a modular tool system have been added to CodeWizard, and the custom tool graphics from ToolStore database provide a high degree of simulation. Here's another example of heavy turning with the tailstock in. We've also seen the examples shown previously where the tool mounting block program for your machine can be captured in the post-processor. Do you have other questions like this or other topics? Please contact us to discuss. We would love to hear from you.